Hello. Today we are going to look at the applications that tcpGPS offers us to measure noteworthy points that are difficult to access, such as measuring that tree, where we cannot acquire its measurement directly with the GPS. We have a series of tools to obtain that point indirectly. For this, we can use the intersection tool that allows us tcpGPS linked with devices like this electronic distance meter that allows us to connect the distance meter with the tablet and acquire its distance, its measurement. First, we are going to use line intersection, for which we need to measure 2 points that will define the first alignment and another 2 points that will define the second alignment, whose intersection will be the point we are going to take. We will perform the measurement. I am leaving. To surveying, I take the first point. And now, in the same direction, I take the second point of the alignment. And I have it now. The first point and the second point, and now in a direction as perpendicular as possible, we take the second alignment. For example, 2 points, such as almost 0.3 and 0.4. And there we have the 2 alignments taken. Now the intersection of those 2 alignments would be the center of the tree. I go to the line intersection tool and it tells me to select the first point, 1 with 2. And now the second alignment, 3 with 4. And it calculates a solution for me to do. It would be 0.5, the highlighted point. Similarly, from this position, we can use the tool we mentioned earlier from the electronic device. So the first thing we are going to do is connect it in this case of options. We configure our device with Leica Disto 910 and enter survey mode. Now what we are going to use is the intersection tool. For example, from 2 points and known distance, following the same alignment of points 3 and 4 that we just measured, we will use it to reach that point. I mean 2 points and distance, and we select the alignment 3 and 4. And now it asks me for a distance that we will measure with the rangefinder. We plumb the rod like the tree to measure the distance. We press the button
and we measure
3 meters 0 to 1.
we give it okay.
The application detects a potential conduit very close to the point we just calculated earlier. We press OK, and it indeed calculates a point number 6 very close by
Of the one we just...
If we measure the distances, there is a distance of 2 centimeters. Let's look at the tool. Of intersection. By intersection of circles. For example, considering the previous alignment, imagining that we have an obstacle and cannot measure it. For instance, here on the screen, we have the alignment of points 1 and 2 that we saw. If we had an intermediate point, we could calculate the intersection of a third one that's outside. For example, in this case, 0.4. Using 0.4, let's look at that calculation method. So we go to Tools, Line and Intersection of Circles, and select the first alignment, 1, and the 2. It gives me the alignment, and now from 0.4, I will calculate a radius that we will measure again with the distance meter. We select the point where we will measure it, the 4, and measure again with the distance meter. There we have it, we plumb. Exactly, 303. And here we have 2 solutions, which are the intersection with this alignment, and in this case, the one we are interested in would be solution 2. We accept, and it generates a third point obtained from the calculation, which would be 0.7. And it's approximately in that intersection margin. Likewise, we can use the tool which tcpGPS offers us for circle intersection. In this case, we are going to use the point measured from 0.4. Measure again, plumb, and measure. Okay, 302. Okay. And now it calculates the radius for me. And we're going to go to 0.2 and measure the second circle again, point 2, which is here. And we are going to measure the second point.
We plumb and measure
3.40, okay? And there we have the next intersection. In this case, it gives us 2 solutions for the intersections of the circles, and we choose solution number 1. It goes a little further, but it is feasible. The degree of precision of each tool depends somewhat on the geometry and the precision with which we are working. Well, now what we are going to use, we will generate a point in a certain direction from a point we have measured. For example, we are going to use the intersection tool with distance and azimuth. In this case, we select the tool, select the point from which we will generate the direction, point number 1, and indicate the distance. We could measure it or type it in. For example, we are going to generate a point 3 meters south of the point we have selected. 3 meters. Okay. And the azimuth is measured in centesimal angles. We will use gons, which would be 200 gons to mark the south direction.
Oh, we give you 200.
And okay, from point 1, it has not generated the second point, which would be point number 9. This point number 1 and point number 9 would be a direction completely towards the south, which we could reconsider if we want to mark it with the tcpGPS application. Now we are going to use the tool for points perpendicular to alignment. A very useful tool for measuring points where the GPS cannot measure. We can measure parallels to a specific alignment, like in the case of this wall, following this alignment. I will take the alignment, and as I take the alignment, I will measure parallel points. For example, I stand here plumb and measure the point. I'm going to the next one.
Goodbye.
We talk and look too. We execute the parallel point option, alignment, select the origin of the alignment and the end of the alignment, and measure with the distance meter. We align vertically, and it gives us 2.43. We accept it, and we already have the point offset from the alignment. We continue our measurement and measure a third point. We hit measure, and now we execute the command again.
2 with 4. And we measure.
We accept and have the solution for 0.5 and so on with the rest of the points. We measure and execute the commands.
4 with 6 and distance.
Okay. There we have the points parallel to the wall that we can take because we lose the GPS signal.